Hey guys, welcome back. So in this today's class we are going to solve the one more problem based on the fixed length subnet masking. So what is the given question is that design a subnet that each network has 30 number of the host. It means that what is the given network they have given is that they have given some series. What is that series is 192.168.1 series. We know that in class C we have the three network portions, right? So network portion means replace with the 8-bit value. So 8-bit value, 8-bit value, 8-bit value. Here host portion is nothing but the another 8-bit value. So it means the total length of the IPv4 address is something 32-bit value. Now see that how many host portion we have. This is the last one, right? Last 8-bit, right? So it means that 8-bit value means how many possibilities we will be getting? 2 power 8. It means that we will be getting the 256 unique IP addresses. This is what we called as the classful IP address mechanism in case if you are using the class C network. Now here the question is that, right, so if you are wastaging the 256, if you don't require 256 in our company, the maximum size of the maximum number of the system is 30. Then if you are using 30, so 256 out of 30 we are using only 30, remaining 226 will be wasted. So for that reason we are performing something called as the fixed length subnet masking. So what is the meaning of this one is, now by default we will be having the 256 host. It means that we can provide the IP address for the 256 systems. Now what we are going to do is, as per our requirement, the single network, this is a single network, we are going to divide into the multiple networks. Why we are going to divide the multiple networks means, in order to utilize the particular IP address effectively, right? So here what we are going to divide is, we are going to divide into the multiple parts. That is what we called as the fixed length subnet masking. In fixed length subnet masking means the size of the each subnet should be same, right? So you cannot take one subnet value will be some other value, another subnet value will be some other size, right? Fixed length means the size of the each subnet should be same value. So what is the requirement they have given is that you divide this network, the minimum number of hosts it should be support is the 30, right? So what is our requirement is that, right, so how to find out the host, what is the how to find out the requirement is that the number of requirement of the host is, the formula is something 2 power h minus 2 greater than or equal to requirements, right? So what is the meaning of this one is 2 power h minus 2, what is our requirement, something we required is the 30, right? Now see that this is the 8-bit value, right? Host portion 8-bit value means something, for example, see 8-bit value means we need to consider the power of 2, right? Let me write this host portion, that is the 8-bit value, right? So let it be something 192.168.1. Host bit will be replaced by the 8-bit value, right? So 1 2 3 4 1 2 3. What is the CIDR notation? /24. Why /24? Network portion, network portion, network portion. So 8 plus 8 plus 8 is nothing but the 24. If something this bit value also 1 means, that also we will consider as the network portion. If 0 means, it will be considered as the not network portion, it will be considered the host portion for the subnet mask, right? Now see that this is our requirement. So what is the requirement? Minimum support should be 30 should be there, right? So now whatever the host h value here we are going to consider, everything will be in terms of the 2 power value only. Remember, this is the important point. So either you can take 2 power 1 or 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6 something, 2 power 6, 2 power 7, as well as the 2 power 8. It means that here we have the maximum 8 bit. So only it means that this value represent the how many number of zeros we are going to convert into the ones. That is what we are going to do here. Now if you observe here, 2 power 1 is 2, right? This is the 4, 8, 16, 32, right? So it means that what is our requirement? It should support the 30 host. Now see that here we have the 32, right? So we can happily consider the 5-bit value for the host out of 8-bit value here, out of 8-bit value, right? So this is something like this, right? So out of 8-bit values 1 2 3 4, right? So it is not there. I am going to consider these for the host values. It means that 2 power 5 means you will be getting the 32. In each network you will be getting the 32. Remember one more point, why here minus 2 means, see that. So how many bits we need to consider if you want to get the 30 host? The minimum 2 power 5 is required. So it means that 2 power 5 minus 2 greater than or equal to, this is requirement. As per the given question, the requirement is the 30. Now see that 32 minus 2 equal greater than or equal to 30. Now this condition is satisfied, right? Now it means that we can take the 5 host bits. So now y minus 2 means, in the previous class I have disclaimed, suppose if you have the network series something like this, 168.1.0, then ending series will be something like 192.168.1.63. so out of these 64, right, so you cannot able to use the 1.0 first IP address, as well as the last IP address is 1.63, right, as we discussed in the previous class. It means that network ID, the last, then one more is the broadcast ID. We have the two things, right, which we cannot able to assign this network ID as well as the broadcast ID to the end devices or the computers. So out of the subnet, out of the 64, only usable are the 62 only. One is for identification of the network, another one is for the broadcasting mechanism. So see that, suppose in the given question, if they are asked you to 32 means, now if you take 2 power 5, then it is completely wrong. Why it is completely wrong means, if you are taking the 2 power 5 means you will be getting the 32, but what is our requirement? Let it be 32 is requirement. So you are getting 32. 2 power 5 means we are getting the 32, that is okay, but requirement also 32. Do you think it is correct? If you consider this is the correct means, out of these 32 also, 2 address will be assigned for the, one is for network portion, another one is for the broadcasting. It means that only usable IP address are the 30, but as per the given question, how many we required? 32. It means that we should go for the 6-bit consideration. Remember, this is very important point, right? So this is the formula, 2 power h minus 2 greater than or equal to requirement. In this case, after 2 eliminating also, we are getting 30, so that condition is satisfied, right? So now this is a question. Now here the important point is that we need to consider 2 power 5. So 2 power 5 means what? Let me show here. The given network is something like this, 192.168.1. network we need to consider. It means that 8 zeros essentially host portion, right? So now here we are going to consider 2 power 5 so that we can able to satisfy the fixed size of the 30 host in the each subnet, right? So for example, how many host bits we require? Out of 8-bit value we required only, 5 bits are the host bit. So let me take something like this. I will be considering only these 5-bit values are the host bit value. Right, try to understand, this is important. So subnetting means what? This is actual network. This network we are going to divide into what? Multiple networks. It means that one single network we are going to divide into the multiple networks. That is what we called as the subnetting concept. Now see that this is not required, right? This is host portion right earlier, but as per our requirement, 2 power 5 is sufficient. Now what I am going to do is that this bit I am going to assign to the network portion, right? So by default, what is the CIDR? 8 plus 8 nothing but the 24. Now see that here this bit we don't require, this we assign for the network portion. Try to understand, this is the important. Out of 8 host portion we required only 5. Out of 8, remaining 3 we are assigning for the network portion. Now see that, so 8 plus 8 is what? 24. This is the default CIDR value. Now see that after assigning these zeros into 3 ones, now what is the value? 24 plus nothing but 3, that is nothing but the 27. This is the important point to be remembered, right? Now how many bits we converted into the networks? 3 bits, right? These 3 bits we converted into the networks, right? So it means that again we have the 2 power n formula. So how many networks we will be getting? Something 2 power 3. 2 power 3 means 8 networks we will be getting, right? So 8 networks we will be getting. Let us see what is the size of the each network. 32, right? Out of 32 we will be using 30. One is for the network ID, another one is for the broadcast ID, as we discussed in the previous classes, right? Now see that how many networks we will be getting? Something 8 networks, right? Let me write 1, 2, 3, 4, 5, 6, 7. One more is the 8 network, right? So what is the C? Each network we are going to divide it into the 8 parts. Each subnet will be consist of what? 32, something 8 portions we will be considering, right? So now what is the starting value of the first network ID? 192.168.1.0, right? So next network is nothing but 0 plus 32. Each subnet will be added with the 32. So 0 plus 32 is nothing but what? 32, It means that second subnet value is something 192.168.1.32, right? So next again 32 plus 32 is nothing but next subnet, right? So it means that what is the next subnet value? Something 192.168.1.64. Next we need to add the 64 plus 32, right? So now what is that value? Something, so 192.168.1. So 64 plus 32 is nothing but the 96. So what is the next network value? Something 192.168.1. So 96 plus 32 is nothing but the 128 value, right? So next, what is the next network value? Again for 128 we need to add the plus 32. So it means that 192.168.1. So 128 plus 32 is nothing but the 160, right? So what is the next value? Something 192.168.1. So 60 plus 32 is nothing but the 192, right? So again, what is the next value? 192.168.1. So 192 plus 32 is nothing but the 224. So 1, 2, 3, 4, 5, 6, 7, 8. So totally how many networks we have? 8 subnetworks. It means that single network we divide into the 8 subnets. This is the first one, second one, third one, fourth, fifth, sixth, seventh, eighth one, right? So this is the starting series. We need to find out the ending series also, right? So now see that how to find the ending series. Now if it is starting from 0, where it will be end? The next network is starting with the 32, right? It means that somehow it should be ended with what? 1.31. If it is starting from 32, it should be ended with 31, right? Now what is the answer here? 192.168.1.63. It means it is ending with the 60, starting with 64 means it is 63, right? So like that you write the remaining portion. So this is what. So for example, if you are considering the first network, so like that we have the 8 networks, right? So out of this, what we have to find out is we have to find this requirement. What is the network ID? Second one is the broadcast ID. What is the first usable IP address as well as the last usable IP address? Then finally we will try to find out the subnet mask, right? So what is the first usable IP address here? The starting IP address is the first usable, right? Sorry, what is the network ID? Starting address, right? What is this case? 192.168.1.0. So last address is what? Broadcast ID, right? The broadcast address is something 192.168.1.31. I'm just considering for this network, right? So now what is the first usable IP address? The first usable IP address is what? So for this network I'm explaining, guys. So 192.168.1.1 is the first usable IP address. What is the last usable IP address? So 192.168.1.30. So for each network, see that this is not we are using for the host purpose. This is not we are using the host purpose. Remaining 1 to 30 only we are using for the host purpose. So for each one, we need to find out the what is the starting IP address. Sorry, it means that what is the usable IP address starting one as well as the ending IP address, like that we need to find out, right? So now how to find out the subnet mask means I have explained, guys. So what is the how to find out the subnet mask? Something they have given 192.168.1. This portion we converted into the network path. Remaining are the host portion, right? So 3 plus 5 is nothing but the 8, right? So nothing but, right? So 24 plus 3, 27, right? So 24 plus 3 is nothing but the 27. So see that this all value will be 8 ones. This all value we are going to write 8 ones. For subnet mask calculation, all network portion should be replaced with 1, right? So here it is anyway 1, here it is all zeros. Then how to write out this one means 0 0 0 0 4 5, right? So it means something we can write 1 2 4 8 16 binary formula is 32 64 128. So just add 128 plus 64 plus 32. These are 0, right? No need to add. So this fourth octet value is something 224. It means that subnet value is constant 255 255 255.224. What? Why 224 means for last 27 the subnet mask is the 224, right? I hope you understand. Thank you guys.